Some new Quad 405 boards have recently arrived, namely the one on the right. If you'd seen my previous video on the Quad 405 clones, this is the one I'd been using. And again, if you've seen the previous videos, one of the boards worked perfectly well, and well, they both did for a short time, but this particular board blew up, not spectacularly, but you'll know if you'd seen the video. The weird thing about this one is I have taken every transistor out of this board and put it on the transistor tester, and they all measure fine. What they don't do, of course, on the transistor tester is they don't feed the voltages in the same as you would on a board like this, which would have potentially up to 100 volts in certain circumstances, well, at least 50 volts anyway, as it's a split power supply. And the transistor testers are fine with running on 6 volts or something like that. So I don't know where to go on this particular board at the moment, other than just go through and replace every transistor. Now, I've looked at these power transistors, and these have to be fake, because you can buy that number from the likes of Farnell and places like that, but buying a pair of these costs more than the whole kit. So these are almost certainly fakes. So whether that's what's failed or fails under high voltage, I don't know at this stage. The main differences are they come without any heat sinks, and quite clearly I'm not expecting this to work as they're not connected yet, simply because I haven't decided how I'm going to heat sink it at present. But the rest of the board is assembled, and there are some noticeable changes. Simple things like the fuses are either side of the board, whereas opposed to the first board they were all on one side. And there's a couple of other small changes in resistor values, and for example this little capacitor here, which is 3.3 picofarad, isn't on the original board at all. But I'm not expecting there to be any huge performance differences. The main thing is I didn't like the way the original board mounts the transistors on this L bracket, and then you mount the L bracket to the heatsink. And in particular, you'll note the absence of the driver transistors here, but that's a very small piece of metal to transfer the heat from that. And I found that those driver transistors, this particularly as they're made of plastic, there's no metal substrate to them at all, and they'd run very hot. So these are the same nasty plastic transistors, which is a KTA 1659A. On paper they are quite a high speed transistor and quite a good one, but my reservations are the back is plastic, and I can't help thinking that's not a good way to transfer heat. These are a very meaty transistor, and I don't think they're fakes. When I plug them in and they go bang, I might have to eat those words, but they are a 2SC520. Quite a powerful transistor, 15 amp rating, 150 watts dissipation, and they're in a TO264 package. And they're capable of running up to 130 megahertz, which I don't think will be going quite that far. And they're capable of dealing with 230 volts. Again, we won't be going anywhere near that. And its full description is it's an NPN epitaxial silicon device. Quite heavy, I have to say. Maybe because they put rock inside it, I don't know. I'm getting very critical and skeptical about some of these parts supplied. As per the last kit, this is an LJM special. Layout is pretty good. The board is relatively thick and all the component values are marked on the front. It's a double-sided board, as is evident here. Where the traces need to be, they're somewhat bigger, and I quite like the PCB, to be honest. Assembling these boards proved no problems at all. They're the fuses I was telling you about, which are together on one side on the previous board. All the components, there was no shortages. The only thing I've done on here, learning from past experience of the other ones, you'll see any of the resistors that generate a bit of heat, I've stood well clear of the board. And that should, I don't know why I did it on a couple of resistors on the other board, but I never imagined they were going to get as hot as they did. So anything that's more than the standard quarter watt or eighth watt, I've actually mounted away from the board. And the other thing I've done, you could argue it's good or bad practice, I don't know. You can see these small transistors here. I've mounted them quite a way off the board, not because they're going to get hot, because I hope they don't, but simply if you're trying to measure voltages and things and you mount them too near the board, you can't get your test leads in them. So that's why I've done that. And also, if I need to remove them, I haven't bent over the leads on the other side. The transistor I held in place with a bit of blue tack, and so if I need to remove the transistor, I've only got to heat the pad and pull the transistor out. So when you start building these things, you never think of things like that because you always assume it's going to work. And well, sometimes they don't. Sometimes it's my fault, sometimes it's wrong components, bad components, but as per usual, I've tested all the components on meters, the transistors, I've checked them for gain, all the good stuff that you should normally do. So providing I haven't made any mistakes in building, it should theoretically just work. Now, normally what I do is to build both boards and then test them one at a time. But what I've done on this one, I've only assembled one of the boards. I'll tell you why. Because a lot of the resistors, once you mount them, you can't see the values anymore. So I'm going to test the made-up board first of all, and if all is well, I'll make the second one. But it's handy, as there's no circuit diagram or any information given as per usual. At least I've got this as a reference to say, oh yes, that should be a 1K, and then I can measure it rather than, well, you're stuck, aren't you? You can only measure what's there, and if both boards are built, you don't know what the resistor should be anyway. Anyway, so that's the plan. I'm now going to find a suitable heatsink to mount the transistors on, and then I'll throw some volts at it and report back. It's connected up to the heatsink, and a woefully inadequate heatsink, hence the fan. My main heatsinks, which that's another project which I haven't finished editing yet, but it's on its way soon. Much more exciting than this one. So what's the verdict? At the moment I'm using my lab power supplies, and I've only got plus and minus 30 volts. So that's quite a long way down from plus and minus 50 volts, but it does have current limiting on, which is most important when you're first powering up. With that, we're not going to judge power other than to say with that particular voltage power supply I get 40 watts per channel, per mono, because I've only got one built at the moment. That's just prior to clipping. Now, apologies for the dreadful state of my workbench, but I am actually filming 3 separate projects. on the same bench, and I've actually gone over onto my wife's sewing table, which she's not impressed with, I have to say. As I noticed with the other quad boards, it clips not symmetrically. Here we go to have a, now you can see it's clipping at the top but not the bottom, and that's at full power 41 watts, and you have to go up quite a bit more before the bottom starts to clip there, and that corresponds to 47 watts. So whether it will clip symmetrically when we have the full plus and minus 50 volts on it, I don't know. This is actually the 20 kilohertz square wave at about 12 watts output. Trying to do mental arithmetic in my head, it's not easy. There's no ringing on it like there was on the previous module. It is better. I've just looked at the old video I made, and this particular module does have a better square wave at 20k, and I can only really put it down to the output transistors, I think, because the rest of the circuitry is near as damn it the same. So there you are. If you're going to buy a quad kit, this is the one I would buy, not the one with the TO3 suspected dodgy transistors. A few other parameters that are slightly different. Basically it's the output transistors that are the main differences. I think these are probably a more modern transistor, well, they are a more modern transistor and a better specified one than the TO3. The half dB points are much higher on this module than the previous quad at 27 kilohertz, which is quite a respectable half dB down. And the low end is still much the same, half dB down at 22 hertz. So half a dB is not a lot, but when you compare it with the L12, L15, it's poor. No doubt about it. I'm not going to show you all this again, because looking at just sine waves, once you've done it once, you've done it enough times, haven't you? Unless there's something spectacular about it. But the square wave performance is pitiful. Exactly the same. Well, I haven't got the two side by side to test, but from memory it's slightly better on the high frequency square wave, simply because this module doesn't roll off so much at the high frequency end. But the 100 cycle, listen to me, the 100 hertz square wave at 50 hertz is just awful. I mean, it's not square. And when you go up to 20 kilohertz square wave, again, it's not nice. If it was you, you'd be going to hospital for treatment. So I don't know why I actually went out and bought yet another set of these boards, because in all honesty, I don't think it's a good amplifier. Its square wave performance is poor, its rides time is very poor, and that will have an impact on sort of dynamic, but the speed of the amplifier. You know, when you get that crash of cymbals or something, it just doesn't do it for the quad. But the quad's got a very pleasant sound, just like valve amplifiers, so a lot of people will like them. But as for a true reproduction of music,